Okay, this is chapter 7, and we're going to be talking about section 5, which is we're going to solve more equations and solve more formulas. So we're still working with linear equations in an unknown variable, and we're still going to solve some formulas. So this time we're kind of adding some parentheses. So if we have this equation right here, 2 times the sum of x plus 4 equals 27. The first thing that we're going to have to do is we're going to have to use the distributive property and get rid of the parentheses. So when you see parentheses, what you have to do is you have to know, okay, I've got to multiply what's on the outside of the parentheses by both the things on the inside. So you're going to do 2 times x, which would get you 2x, and then you're going to have to multiply the 2 by the 4, which would get you a positive 8 equals 27. From there, we know that we need to go to the side with the variable on it and get rid of the thing that's not connected to the x. So we want to get rid of the plus 8, and we would do that by subtracting 8 from both sides of the equal sign. 27 minus 8 would get us 19. And then we want to bring down our 2x. Our 8 minus 8 turns into 0 and cancels out. Okay, the next thing we want to do is it's 2 times x, so we want to divide by the 2 in front of the x. And 19 divided by 2 would get us 9.5. which is what they've got. Now we could also go back and plug in our 9.5 and make sure it works, which is what they've done right here, to see that if you plugged in 9.5 for x, that it would end up being 27. Okay. Let's go ahead and look at example 2. Now, when you have parentheses and there's a negative in front, you're going to have to remember that a negative sign means opposite. So we're really saying opposite of 2x and opposite of negative 3, and we've got to deal with that first. So the opposite of a positive 2x would be negative 2x, and then we need to do the opposite of a negative 3, which is going to turn this into a positive 3. Now we want to combine like terms. We've got 5x take away 2x. Well, that's going to be 3x plus 3 is equal to 27. Now we're to the point where we can start solving this. So we're going to subtract, to get rid of a positive 3, we're going to subtract 3 from both sides of our equal sign. That's going to be 3x is equal to 27 take away 3, which is 24. Going to divide by 3 on both sides. And so 24 divided by 3 gets us 8. If we wanted to plug the 8 back in and check that, 5 that when we plug it back in, 5 times 8 is 40. 2 times 8 is 16, minus 3 is 13, and that is equal to 27, so we're correct. You can always plug it back in and check it. Okay, so when you have a variable on both sides, in all the equations we have solved so far, the variable has been on one side of the equations. Sometimes it's necessary to solve equations with variable terms on both sides. So when we have a variable on both sides, like this problem right here, we've got 3x minus 4 equals 8 minus x. It's going to be important that we get all our variables on one side of the equation. So I would have two choices here. I can move this 3x by subtracting 3x from both sides, or I can move this minus x by adding x to both sides. I like that option better, but both of them will get you the same result. So 3x plus an x is going to be 4x, minus 4 is equal to 8. A negative x and positive x cancel out. Now we've got our goal of moving the variables to one side of our equal sign. So we want to go to the side with the equal sign and get rid of the thing that's not connected to the variable. So we want to get rid of the minus 4 by adding 4 to both sides of our equal sign. That's going to get me 12. I'm going to bring down the 4x. The negative 4 and positive 4 turned into 0, so it's like they canceled out. And 4 divided by 4 is 1, so x is 12 divided by 4, which is 3. We could plug that back in our equation. So wherever I see an x, I'm going to put blanks there, and I'm going to go in and plug in what I think is correct. So I'm going to put a 3 here and a 3 here. 3 times 3 is 9, minus 4 is 5. 8 minus 3 is 5. So the solution 3 is correct. Remember, do only legal operations. Add or subtract the same quantity from both sides of the equation. Multiply or divide both sides of the equation by the same non-zero quantity. Remove all parentheses carefully. Combine like terms when they are on the same side of the equation. You use legal operations to change the equations so that you have only the variable by itself on one side of the equation and a number on the other side of the equation. To avoid errors, be sure to check your answer. To solve a formula for some letter means to rewrite the formula as an equivalent formula with that letter isolated on the left side of the equal sign. Solving formulas is a very important practical application of algebra. Very often, a formula is not written in the form that is most useful. To use it, you may need to rewrite the formula, solving it for the letter whose value you need to calculate. To solve a formula, use the same balancing operations that you use to solve equations. You may add or subtract the same quantity on both sides of the formula, and you may multiply or divide both sides by the formula by the same non-zero quantity. So in this equation, they're wanting us to solve the formula S equals R plus P divided by 2 for R. So they're wanting us, in the end, they're wanting us to say R is equal to. Okay, so what we have right now is S is equal to R plus P divided by 2. And I want to get R by itself. So I can start by trying to get rid of this divided by 2 on the bottom by multiplying both sides by 2. So if I multiply both sides by 2, well, on the left side, that's going to get me 2S, and I'm going to put a line through that S so it doesn't look like a 5, is equal to. Now what happens over here? We've got a 2 on the top and a 2 on the bottom, so those cancel out because 2 divided by 2 is 1, and we've got R plus P. Now I'm very close to getting R by itself if I can just get rid of this plus P. Well, we could subtract that, and that would get us 2S minus P is equal to R, which is what we need. R is equal to 2S minus P, not B. Okay, so that's how we're going to move that equation around. The equations you learn to solve in this chapter are all linear equations. The variable appears only to the first power. We don't have any x squareds or x cubes, x to the third power. Terms appear in the equation. So we're really dealing only with linear equations in this section.